Hi and welcome to the second part of this hybrid tube amplifier video. In this part I'll talk about the individual completed PCBs. These are the main amplifier board, the LM3914 battery level indicator, the ABLIC S-8254 battery protection system, the TP4056 battery charger, and the M18 Bluetooth receiver. You'll find the links in the description for the EasyEDA project, along with links to more detailed videos. This is the completed board. So I'll start off with explaining some of the connectivity. So this large red connector here is the 12 volts in. Needs about 1 amp and the board is unregulated, so it needs to be regulated to volts. This one here is the Bluetooth switch with a LED output connection as well. This one here is the 12 volts out for the Bluetooth module power supply. This yellow one here is the power indicator LED. This one here is the line in, Bluetooth in, and headphones out. I've incorporated the 100 volt booster onto the board. So this is the onsemi UC 3843B boost converter IC. It uses traditional design of using an inductor to boost the voltage along with a Schottky diode. So it outputs 100 volts. It can be increased by changing the voltage divider here. Some of the components like the Schottky diode will need to be changed to allow for the higher voltages. The plate voltage is dropped to about 85 and 90 volts depending on the tubes used by these resistors, and the bias is set accordingly. Under each tube there's 2 sets of LEDs, which is controlled by this connector here. You also have pre-out, which is straight from the tubes and not through the op amp, so the headphone is driven by the op amp. The one I've used in here at the moment is OPA 2134PA. I've tried different op amps and it does sound different. This bit of circuitry here is the relay control. So there's a delay when you switch it on before the headphones are connected to the output. This LED here is part of that circuit, and you can turn it off should you wish. This relay here is used to switch between line in and Bluetooth. Nearly most of the components are surface mount. Some components I avoided using surface mount because these are audio series capacitors by Nichicon. These are the fine gold version, slightly larger than normal capacitors. You've got audio series power capacitors here as well. So there's a single ground plane on the top. It seems to work really well. I can hear no hum or hiss when running on battery. I think there is a slight hum on the right channel when running on mains, but that could be due to me testing with bare wires and so on, and other sources of interference, but it certainly wasn't noticeable when something was playing. Limited ground planes on the rear and no components on the rear. These are just some washers that I've glued on ready for mounting into an enclosure. So just going to put some tubes in. These are here the popular GEJAN 5654s, which sound very warm to me. These ones here are Raytheons. They sound a bit muddy to me, so just going to pop these in. So it's quite easy to do a bit of tube rolling with this. The tube holders are ceramic gold plated, so the overall height from the top of the capacitor to the spaces on the board is just under 20mm. The width of the board is 105mm by 85mm, I think. Let me just double check. $75mm. This is the PCB. I try to optimize the placement of all the components to keep the board down size and to keep the noise level down. All components have their values written on the board. And this here was the prototype that I built, which was susceptible to noise. As you can see, it has a external 100V booster. I've done separate videos on all the modules that I've made. So this board does run just with a 12V power supply, line in and headphones out. You don't need the other modules that I've made to use this board. How does it sound? It sounds absolutely amazing. Tried different headphones. I haven't tried any high impedance headphones. I don't have any. I've been using 32 ohm headphones and it gets very loud. So very impressed with the sound output on this. Here is the completed LM3914 battery level indicator. This is the PCB that I designed, made it as compact as possible. So one side has the LM3914s, which is this side, and then this side is where the LEDs go. The LEDs I got from AliExpress, because these LEDs I've not really seen them on eBay. Seem to be quite expensive. They're just multicolored ones. So you got a DP/DT switch here, so each switch turns on 2 LED modules. I could have done it with a single 4 switches and a single LED module, but that would cause problems with the circuitry that I'm monitoring, because it was kind of short some of the batteries across various different circuit paths, which I want to avoid. Using JSTs for the battery connections. And you obviously have adjustable potentiometers, 2 for each segment, the upper and lower voltage thresholds. These are fake LM3914s. I have some genuine ones, I just haven't installed them yet. The capacitors are there for stability reasons. Made this according to the manufacturer's spec sheet. I made this module because I needed 4 chargers in one. I could have used these ready-made modules, which are TP or TC4056s, but they're separate modules and they have problems. Quickly talk about this circuit. You see a lot of these on eBay and a lot of people use them and swear by them. Number one, the resistor R3, which is just there, which I've replaced using a non-service mount one. It's set to, I think, 1 kilo ohms, which means it charges at a maximum current of 1 amps. So I'm trying to charge 4 batteries using a single power supply, plus I need overheads or more current capacity for other things in the same circuit. It's a lot of current. Also the small footprint of this PCB means the heat transferred, you can see the little vias from the TSOP8 package. It's actually a lot of heat generated when you feed 5 volts off it. So if your supply voltage is 5 volts, which it would be if it's USB, and your battery is discharged to 3 volts, so the power dissipated by each of these ICs would be 2 volts, which is the difference which it has to drop because it's a linear regulator, multiplied by the current. So 2 watts would be dissipated when the battery is at 3 volts. Obviously that power dissipation goes down as the battery voltage increase. So this gets toasty. I measured this at between 70 and 80 degrees, I think a bit more depending on if your battery is lower than 3 volts. So it gets toasty. I'm pretty sure that temperature is close to the operating life of these LEDs. Also, all the components are questionable. So this says TC4056, which I believe is a clone of a TP4056. I don't know if they're fake or not. It says on the spec sheet it's made by AMS, but it has questionable tolerances and charge cutoff voltage. I found these go above 4.2 volts, which isn't good. This also has a protection for discharge cutoff, so you can use this to run your batteries as a power supply, obviously individually. So not good enough for me. Don't trust the accuracy of these components. So I looked up TP4056 and found the genuine top power modules, which are the newer revision. They're called TP4056X, so they have much better tolerances. So the overvoltage detection has an accuracy of 1% as opposed to 1.5%. This is the PCB. I made another version of this earlier. PCB was too small, so heat wasn't being dissipated properly. So under each IC, there's a thermal pad with vias to the other side for heat dissipation. It's designed according to the manufacturer's spec sheet, so I would say it's the same as this, minus the protection, which I don't need. So it's just purely a charging circuit. It's been designed for my purpose, hence the reason for this layout and the multiple output pins. So you've got 2 5 volts in, so 2 of the modules are so it's 2x2 modules from the power supplies, and the 4 battery outputs and a single common ground. The rear, there's space for mounting heat sinks, which is very necessary, and then you have 2 watt resistors for additional power dissipation. So it's actually been designed to be mounted upside down. So here is a closer look at it. You've got the LEDs at the bottom for the different charge and standby statuses. I used thermal glue to mount the ICs and then soldered the pins. And then 6 11 by 11 millimeter by 5 millimeter height heat sinks. It's based on the ABLIC S-8254 IC. It offers charging and discharging with various different cutoff and over discharge voltage ratings. I'm using this only for discharging and not charging. It can be used for charging, but I'm using a separate module for charging. So I made 2 versions of it. So the first version is smaller PCB and it works absolutely fine. The only catch is, according to the manufacturer's spec sheet, that when you connect the batteries, it says sometimes the circuit will not activate. And I found to be the case nearly 100% of the time, which meant I then had to short two of the pins as per the manufacturer's spec sheet. So it says you need to short B plus to pin 2. It doesn't say in the manufacturer's spec sheet, but you can short B plus and P plus, and that has the same effect. This is actually the same with these modules that you buy on eBay. So it's the same chip. I believe they're fakes because this number on this chip doesn't match up the spec sheets of the manufacturer, and the cutoff voltage is very dodgy. I think this one is at 2.5 volts, which is very poor. Didn't like them. So these ones you have to short the pins. It doesn't say that. I think a lot of people connect the charger up to activate them, so that could be a problem if you haven't got a charger next to you. Here's another version of these boards using the fake S-8254 chips. This one, I don't know what they've done to it, but when you connect the batteries up, most of the time it auto activates. So the ICs that I used on these boards has a discharge cutoff voltage of 3 volts, which is the maximum one I could find to buy. Here is the other version of the board. So it has additional components here on the right hand side. This is a relay activated self reset, so whenever you connect the batteries it shorts the pins as per the manufacturer's specification, using a circuit that I designed. Basically it means as soon as you connect the batteries, within 2 seconds you get an output, and you don't have to do any manual shorting yourself or apply a charge to get the power output. Some components on the rear side as well. And it's the same on this one. So you've got P plus, B plus, P minus, B minus, and the battery monitoring balance, well not balance wires, but wires that go to the batteries. This is not a balance, it's just a protection. So the first version, here it is, works. You've got power MOSFETs, I think they can do up to 3 amps, but I'm only pulling 1 amp so it doesn't get hot at all. You've got a current sense resistor here. There's the S-8254 genuine version. In the rear. Here's the one I'm actually using in my project. So there's the rear, the components on the back. And then the front, there's a relay and 5 transistors which do the delay activation. So when you apply power, there's a delay before the relay activates for about a second before it deactivates. And I've decided to add additional stuff like power indicator LED set to very low brightness, and the relay activation LED. Here is the completed Bluetooth module. So this is based on the M18 Bluetooth module that you can buy readily on eBay. This is the only thing that I didn't make myself. So I made a power supply board for it and a connectivity board. So this on its own wasn't good enough. Number one, it doesn't have a voltage regulator, and it's all Castell holes or PCB pin holes that you have to then mount and solder in. So I thought I'd make this so I can use my own JST connectors. And I also found it's noisy because of ground loops. So with my amplifier it caused a ground loop. So I used a this 12 volts DC to 5 volt isolator. So it has 2 separate grounds. So there's isolation on the ground. It's the Monsun B1205XT I think they use quite a lot to provide ground isolation. So the additional components here are for filtering out noise, ripple. It seems to work really well. It seems to be quite clean. So this one here is the input or output, sorry, the Bluetooth output. The red one here is the 12 volts DC in. This one here is the play, pause, next and previous controls that are optional. And then this one here is just LED output pins that have resistors under the board here. Should you need LEDs for the buttons, so it's optional. The buttons aren't needed. I'll just put them in there just in case they're needed. So this module is going to be part of the hybrid tube amplifier input. And then here's the PCB. Nearly everything is surface mount apart from the JST connectors.